Okay.
You beat me to it.
I hope that you guys are okay with us recording this, but just in case folks are not able to join us, we'll give it a couple more minutes to see how many more folks are gonna join us. Just looking to see who's here. Okay. I hope everybody's doing well.
Indeed.
Indeed. It's been a long day of phone calls today, so phew. This is the last one, so hopefully we'll and yeah, so just so you all know, this is our second informational webinar. Today we're going to focus a little bit more on the final deliverable, and Charles is going to help us by showing us some examples of some technical documentation that we might be expecting to see. And I'm going to share with you an example, more details of an example hybrid system, renewable energy demonstration project. But we're hoping that we won't take more than 20 minutes or so to go over that part. So we'll leave lots of time at the end for folks to share their progress and any challenges and just kind of go around the room and hear what's going on. So with that, I'm going to go ahead and just get started. And if folks start to join us or continue to join us, then they'll just come join the conversation when they're ready. So again, thank you guys all for being here. I just want to maybe go around the room if we can do the, the Brady Bunch thing, right? Where you introduce yourself and then introduce the next person or pick the next person to be introduced. Just so we know who's in the room here, and then we will get started. So you all know me, I'm Remy. I'm with Repowering Schools, and I'm going to pass it off to Hamed to say hi and introduce him and his students.
Hello, everyone. Good to see you. Yeah, I'm Hamed Nademi, Assistant Professor of Electrical Engineering at California State University, San Marcos, and I'm here with my two students as part of this project.
I'm Chris, and I'm a senior here, electrical engineering student.
My name is Miguel, and I'm also an senior electrical.
Wonderful. You want to hand it off to the next person?
Pick someone else.
Okay, Ryan.
Hey everyone, I'm Ryan Fontanez. I'm at Oberlin College. I'm a junior here studying computer science. My partner in the project is Otavio, but he's not here right now. But he's also a computer science and 3-2 engineering perspective major. Yeah. And I'll pass it off to Jonathan Miles.
Remy, can you hear me?
I
Yeah,
can.
hear you.
Okay, I'm sorry, I'm in the car here. If it's okay, I'm going to defer to, I think I see Stephen and Nick on the call here. Or Remy, if you could cover for me, I'm a little bit trying to deal with driving at the moment, if that's all right.
No, that's fine. So John is over at James Madison University, and Nick, do you and Stephen want to introduce yourselves?
Yeah, sure. I'm a senior at James Madison University. I study integrated science technology. I have Stephen with me here today, and then we have two other teammates as well, but they weren't able to be here. So Stephen and I are filling in for them.
I'm Stephen, also senior ISAT and economics major. Yeah, working with Nick and Miles.
Yeah, and real quick, I'm in a little better place right now. Sorry, I was maneuvering. Yeah, I'm John Miles. I'm a professor in the School of Integrated Sciences at JMU and also director of the Center for the Advancement of Sustainable Energy. And look forward to advancing on this. Thank you.
Awesome. Well, I'm going to just select Sohad to say hi and introduce your team.
Hi, everyone. I'm Sohad Elzaid. I'm an assistant professor at Appalachian State University, Department of Sustainable Technology and the Built Environment, with electrical and energy engineering background. My student here, I see Duncan. I don't see Joey, so I'll pass it to him.
Yeah, I'm Duncan. I'm a student at Appalachian State University. I'm a first-year graduate student. I'm studying renewable energy engineering. And I'll pass it off to Jeff.
Hey, my name's Jeff. I'm a student at UMass Amherst, mechanical engineer, and I got a couple teammates in here. I'll pass to Jacob.
Hi, I'm Jacob. I'm also part of their team, also studying mechanical engineering. I'll pass it to Jake.
Hey, yep. Same thing as them. I'm a mechanical engineer and from UMass, and I'll pass it to Stephen.
No, I think Stephen already went. So how about Jim?
Hi, everybody. Jim LeGrant, professor of practice in manufacturing at UMass Amherst. And I'm going to pass it over to another one of my students, Grania.
Hi, I'm Grania. I'm also a senior mechanical engineering student. We have one more group member, but he wasn't able to make it today. So I'll pass it to Charles. I don't know if anyone else hasn't gone yet.
Charles Newcomb with Repairing Schools. And I'll pass it on to Jin, because I can pronounce that, I think. The last of the two. Jinjo.
Hey everyone.
Hey Jen.
And my name is Jinjo. I'm at ISU, Illinois State University. I teach here in the Sustainable and Renewable Energy program. I'd like to check out your proposals, exciting opportunities, and so on. Thank you.
Awesome. And Jin told me earlier this month that he has a renewable energy demonstration project on his campus. And so I thought maybe he would have some insight as you guys are building your own projects. So maybe he can be a resource as well. And then Yuan, you would be the last on my list.
Hey, hello. Can you hear me?
I can't see you, but I can hear you.
Can you see me now?
There you are.
Okay.
It's like magic.
Nice to meet you again. Yeah. Hey, hello, everyone. My name is Yuan Xi. I'm a faculty working in the California State University, Fresno. We have 3 students right now in my team, but I don't think they are here because they have class today. So I will forward the information to them. Nice to meet you all again. Thank you.
Nice to see you. And we are recording this. So for any of your teammates who aren't able to be here, I will send a follow-up email and they'll be able to watch this recording later.
Sounds good.
Wonderful. Okay. So the main goal of this webinar is again, for you guys to ask lots of questions and to, talk to each other about where you're at. But I wanted to remind you that we have a deliverable coming up, and this is the kind of the main deliverable, right? We're looking for a complete design of the hybrid system to include schematics and parts lists and costs. And we're going to go over all this good stuff. You should also describe the application for the system. So what you're trying to do, what your client wants you to do with this, with the system, as well as any considerations for system implementation. You guys will be completing these and submitting these to us by the end of December. And we will have a panel of experts who are going to review those and give you feedback. So it's not like a grade, it's not a pass or fail. The idea is for you to get some industry experts to review it and give you really good feedback so that you can progress to the next part of the project, which would be implementation in the spring, if you and your client would like to do that. Again, it's not required. So if you're done, that's fine. But know that that's, the next phase of this. We will also like to showcase some of the top designs on the Repairing Schools website as DIY renewable energy demonstration projects, because we get a lot of schools who will ask us for these sorts of things. And rather than having to do a custom design every time somebody asks for one, it'd be great to have like a selection of different types of renewable energy systems that do different things that a school might say, oh, I like that one. And they can download some of these technical documents and hopefully get started without too much hassle. So, so that's the aim for the end of December. But I'm going to turn it over to Charles I hope that's okay, to go over the next part of this, to give you some more details on what we are expecting to be in the design report.
Yeah, thank you, Remy, very much. So I think the first thing to acknowledge is that we have a range of folks. We have folks that come from non-technical colleges, sometimes technical under, 2-year colleges, all the way through these, graduate level electrical engineers. And so it's important that you understand that we understand that there's going to be a spectrum of comfort level with these kinds of things. Some of you may have never thought about the ampacity or the allowable current that might flow through a wire ever before in your lives. So we know that. And some of you you're like, that was so 5 years ago when I was in electrical linear systems or something. And so there's going to be a range of comfort levels, and we acknowledge that. So in that vein, this technical report is meant to be, as Remy described, kind of a snapshot into what you're doing. If you have the time, inclination, capability to make something amazing so that we can highlight it for repowering schools and for other folks, then your compensation will be knowing that your design is being replicated in lots of places because it's easy to follow and easy to do. If on the other hand, you're like, I got a lot going on and I have just enough energy to do kind of the minimum, then that's okay too. I think our objective is to be able to suss out those folks that are interested in going forward in the next semester and getting a sense of how much additional support they might need or how the support's been working for them. And so this is not meant to be a PhD, let alone a master's level document. It's meant to be however many credits you're getting for this class. Some of you might be getting no credits. Some of you might be getting 1, and in which case, then you put in an appropriate amount of effort. It's not meant to be something horrible for you. It's supposed to be a learning experience and fun. So the executive summary, we'll leave that to the end, like you always leave the executive summary to the end. The summary of the application, again, these things, you might even be able to put two of these bullets into a single paragraph. That's kind of what I'm thinking. It would be nice if the summary of the application was sort of a description, gave us a little narrative about the place, who's going to be there, how often it's going to be used, who's going to lay eyes on it, why is it useful, that kind of thing. And what's, why. So if you have it, like, imagine if you had it in a classroom, be like, I already have plenty of light in here. Do I really need a demonstration in the classroom? If on the other hand, you're like, it's really hard for people to charge their laptops off the picnic table because there's nothing out there. Well, that's a big difference. So that kind of a thing, when we talk about these small hybrids, the value is really about the use. And so if it's just providing additional light in a parking lot, it's of some value. But if it's providing the only light in the parking lot, that's of much higher value, obviously. So that's why the application, sort of the summary of the application, is valuable to us. The description of the load, this gets into, sort of what are you designing for? If you have a few $1,000s, there's no way you're going to run a milk, processing plant, let alone a house. You might be able to, segment out some of the load of a campus building or something like that and say, hey, we're going to be doing the lights on the volleyball court or something like that, and behind the student union or something. And that's fine too. But the description of the load gives us a sense and you a sense that what you're trying to do, and whether it's realistic, and how much it's being used, and how big it is. So you're gaining, if you're not a, master's electrical engineer, you're gaining a little bit of a closer relationship with energy by thinking about this. And so this is an important exercise, and sharing with what you did, either in a table form or narrative form or whatever, pick your poison, is important to us. We talked about modeling last time a little bit. There are some very sophisticated models out there, and there's some really beautiful, Homer, H-O-M-E-R, homerenergy.org, I think it's org, or maybe .com, is owned by UL, so it must be on .com, is a very amazing modeling tool. And it gives you what I love about it is it kind of gives you these sensitivity analysis and teaches you what's important. So if you change the amount of light that lands, or the solar radiation that lands, by 15%, it'll tell you what it does in terms of changing the battery size, or how many fewer loads you can run or whatever it is. And so Homer is a great one, but this is a tiny little hybrid project, and Homer is probably overkill. If you have access to it, awesome. I wouldn't spend well, you can get a day pass, I think, or a few days pass. You might have to look into that. So that's something to consider. Or if you just want to do PV watts, which we introduced the last time, and the WinCAD model out of Berge, that's totally fine too. The objective is to give you an introduction to what is it like to model something and we're not talking about MATLAB modeling. We're just talking about some sort of investigation, some sort of numerical investigation into what this thing is going to do. And then finally, we have this proposed design that says, okay, based on needing this kind of energy to run these kinds of loads for this amount of time over this period of the year or whatever, we think, based on the modeling of here's how much a unit amount of solar panels are going to produce, or this wind turbine, the small air turbine, this is what we think is going to work. And so that proposed design is kind of the crux of this thing, if that's the right use. It's the culmination of what you're trying to do and say, okay, we've thought about this a bit. This is what we want to build. And then we have this thing of summary of testing. That's a little tricky because you don't have a system built yet. You haven't even gotten any money to build anything. So what testing could you possibly do? Well, you could do, going out and looking at where the shadows are. That's sort of a testing to sort of say, hey, what kind of shading do we might get on these panels? Or if you went out and you took a solar shade calculator, what did that look like? Or if you measured the LEDs, because an LED in a dimmer switch may or may not be dimming the actual power requirement of the whole circuit. It may just be shunting some of the power into the switch itself, those kinds of things. So that kind of testing, we would like to hear about. How do you know how much power you're going to use? That kind of thing is useful. And whether you use a kilowatt kind of plug-in thing, or whether you use, kilowatt being that little plug and you plug something into it and tells you how much power is being used, whether you use a data acquisition system, whether you use a clamp meter and made some assumptions, we don't really care. It's always good on these kinds of things to familiarize yourself with some sort of testing, and then write it up a little bit about it, just a paragraph or something that just or a table that says, here's what we did. The considerations for system implementation, this kind of goes back to, well, I want to do some circulation of the water in a pond and keep it from freezing, right? Because it helps with the fishing, something like that. You're like, okay, great. How are you going to get it out there, right? You're going to tow it out there. You're going to swim out there. What are you going to do? Because it doesn't magically appear. We put a wind turbine once upon a time, not a big one, just a little 50 kilowatt, out in a lake. And we did it when the lake was dry, and it was really easy to build it. And we drove the crane out there and we put the turbine in, and then they flooded the lake for us. And then nobody thought about how to get to that turbine to maintain it. It was like, so those are some of the implications of your choices. So think about those kinds of things. If you're going to put it on a mountaintop, how are you going to get to it to service it, that kind of thing. And then the summary or risk analysis, what are the things that could go wrong? I don't think we need a long narrative around, wires and fires and that kind of stuff, more along the lines of, what if there's a turbine that's spinning and it's right above the picnic table where you have kindergartners with balloons, that seems like a bad idea, something like that. But if you have a turbine that's spinning and it's 15 feet in the air and it's around sort of responsible people, that's okay. If you're like me and you put it on a container as a demonstration right next to a tree, as long as you trim the tree back, that's probably okay. But the branch is going to grow out and intersect with the turbine. Your job is to maintain that tree so it doesn't eat the turbine, that kind of thing. So I think those are examples. And then areas for further investigation, like what didn't you get to? What do you wish you had time for, or tools or money for? On the technical details, again, this can be in the appendix or you can kind of build it in. Doesn't matter, however you want to do it. But a general parts list, sort of a breakdown, a balance of plant or a balance of station, a BOM list is important. A detailed cost breakout, so we have a sense of how likely are you to be successful. So if you're like, I want to do a 100 kilowatt and turbine out of Belgium, and I want to do this 25 kilowatts. Wow, that's amazing. How are you gonna What's your funding mechanism kind of thing? And we would love to know that, because think big. That's okay to think big. You don't have to think small. System schematic. This is, we'll show you some examples of this, but the difference of a system schematic and a single line drawing is that a schematic just sort of lays out, hey, here's a relative, or not orientation, because it's a picture and it says the turbine's over here and the panels are over here, but they could be switched. We don't really care. But it just sort of shows, here's what the major components are. Here's roughly how they're positioned, interconnected, that kind of thing. Whereas the single line drawing, the one line, whatever you want to call it, is much more of a, it's almost like if you were wiring it up, you could follow your one line drawing. You'd say, oh, I know that the solar panels connect to the charge controller. That then connects to the DC bus or whatever. And I understand that. Now, you know, it's not a 3-line or a 2-line drawing, which sort of says, here's the, I'm going to fuse the positive, or I'm going to fuse the negative, God forbid, depending on what kind it is. So there are some negative systems, negative ground systems, and people do that in telecom. All telecom is negative, go figure, but it's minus 48. So the positive is grounded. So, you know, then you'd need a 2-line system to show that. But we're just looking for a single line drawing, something that shows that you understand that what components have to be connected to what, and that they need some sort of overcurrent protection. Everything needs overcurrent protection. Anything that either consumes or produces energy needs to have overcurrent protection, because bad things happen if you don't. And it's really hard to put the smoke back into the wire after it comes out. And if there's a smoke alarm above you when the smoke comes out, that's it's embarrassing. And it also can actually cause damage and fire and all those kinds of things. So let's avoid that. And then the assembly outline, kind of a description of, you know, the panels aren't magically going to hover in the air. They got to sit on something. So it's either a rack or a rooftop, or you could lay them on the top of the shipping container and weld them down like I did once upon a time, or you can do whatever you want. But like, just give us a sense of what's the turbine going to sit on? Is it going to be on a 10 or 15 foot pole, or is it going to be on a 50-foot, you know, telecommunications tower, or on the edge of a water tower leg, or tell us just where it's going to go. And then product spec sheets. So these are the cut sheets, so we can give you feedback. So if everything is Renogy out of Amazon, that's okay. It just may not last very long. So you need to be making sure that you're setting expectations correctly. Let's go to the next slide, Remy. So that's kind of the overview of the design report. We're thinking a few pages. This is not meant to be a major opus magnus or anything. Here's a couple, there's a schematic on the top right, and it kind of, which is really so sweet of you to put this in. I made this drawing back, I want to say in 2002. It's a long time ago. But it does show you that, oh yeah, there's a battery bank, and it's kind of connected to a DC source center. I see a PV array, I see a wind turbine, a generator. You probably don't need a generator, but that kind of thing. Versus the single line. And the single line is kind of fun. It's for a 20 kilowatt turbine we just put in for NREL for Ian this fall. And it's we're waiting for an inverter upgrade. But what we wanted to show you on this is that, oh, we are putting some overcurrent, you know, protection in there. We're showing what it is, what the size of the overcurrent is. We're showing you the wire conductor, the conductor size. So if you come down for the turbine, then it says, you know, there's a little disconnect, which isn't really there. And then it shows you that there's 3 number 3s, you know, and you can look up in an ampacity chart to see what's that good for. Hopefully it's good for 100 amps. And you see the layout, the DC or the dump load box, inappropriately labeled DC. It's actually 3 single phase dump loads, but that's okay. These are the kinds of things you got to put them on paper so you can go back later and go, oh, that's not right. I misread that in the spec sheet or whatever it is. So this kind of thing is very useful. There's a little load center at the bottom that sort of shows there's an inverter controller and VFD or the yaw drive. In your case, that load center can be a power strip. It doesn't need to be anything other than that. It can be pretty darn simple. So don't think you need this. This is not this is a low voltage system. You know, for most of you or many of you, it may be a 12 volt DC system. And it's going to have 120 volts on the AC side, but it's going to be a GFI outlet probably on your inverter. This kind of thing is like, it's not subject to the NEC in the same ways that if you're going to put it in a house, it would be. So that's that one. Let's go to the next slide. So we have time for questions. There we go. There's just an example of cut sheets. If you're going to send us an electronic version, in the appendix, it would be nice if they weren't. I made this little Xantrex one down in the corner, impossible to read, right? So this were on a PDF. that would be just mean because I'm already wearing glasses. I don't need to wear a microscope. So if you can put them as a full page or something so it's readable for people, that would be great. And what we need is the main component. So we don't need the piece of wire and where it came from and all this kind of stuff. It's just show us what the inverter is. Tell us a little bit about the batteries. Tell us a little bit about the solar panel you found or the turbine kind of thing. Next slide. Next slide sort of shows when it renders. This is an example of a single line for a simple hybrid system. And this is actually, we put one of these down in Guyana. So it's running a tiny little village of like 40 people, I want to say, deep in the, not jungle, it's out in the plains, high plains, down in South America. And it has a little satellite modem that talks to satellites. That's the backhaul. And then it's got a little cellular radio, and everybody has cell phones in town now. It's kind of neat, but this is the architecture of it. Very simple. That there's a little bit of solar. There's no wind down there, so that's okay. But it does show you that there's a little combiner box. So when you have, more than one panel and you're going to exceed, the DC rating of their battery, and you'd be throwing it away if you don't have a maximum power point tracker or something, you have to match your voltages. And so we're showing that, we're bringing in multiple strings of PV in so that we don't exceed. In this case, it was a 48-volt system, I want to say. Yes, negative ground. Oh, negative ground. That is wrong. Oops. See, you always find mistakes in your drawings when you go back through them. It's supposed to be a positive ground. Next slide. The next slide shows you the ampacity chart that I was referring to. And this, you just Google, right? Wire amp table, and you're going to come up with this little table here, which says, okay, it comes out of the NEC, and this is, you're going to find a million of them out there. And each one of these things in the left-hand column says, here's the current that you're expecting. Oh, sorry, that's the wire size. And then everything else is the current, the number of the amps. And, you can choose different temperatures. You can choose direct burial. The THHN is probably a nice common one. Is it even there? I say that it's common. There it is in the 90 degrees C, fourth column over. That's a probably good one. You get that at Home Depot. If you want to use the USE is an underground, you can use an SO is like a flexible, weather rated, like an extension cord. And so THHN is wet rated. That's what the, maybe it's THWN is the wet rated. But it doesn't change the ampacity that much. So overshoot a little bit, make your wires a little bit bigger. There are some rules, like your wire needs to have some, 125% or so current carrying capacity in comparison to the overcurrent protection, so you don't burn up wires ever. You can follow those rules. I think it's better to follow them than to run everything right to the edge. We really don't want to have any fires. And the NEC, the National Electric Code, is put out by the National Fire Protection Association. So it's like I put a little guardrail image in here because it's the same notion. They put up guardrails. This may be apocryphal, but I like the story. They put up guardrails where people have driven off the road before and been hurt. So it's not like if you drive off the road because you're out of it and you drive off and you get stuck in a ditch, nobody's going to put up a guardrail for you. But if you fall off the road and die, then they're probably going to put a guardrail there in the future. So that's what the NEC is about. It's written in blood or in carbon, as they say, because, these people have made a lot of mistakes. And when you DIY stuff, this is where it can go wrong. And you wouldn't think, hey, it's just a little battery. It's no big deal. It's just 12-volt battery. And it's a little bit of solar, tiny little wind turbine. How much damage can it do? You know what? One of these batteries is pretty much any battery is capable of burning a big hole in a piece of metal. So don't think they're not bad. I mean, yes, you can grab both poles of a 12-volt battery, nothing will happen to you, no big deal. But when the current starts flowing, because you have very low current, my favorite example was working with another engineer one time. He was feeding in a fish tape into a battery bank, which is a terrible idea if it's metal. And it was my favorite fish tape. And it came back from the trip like 10 feet shorter because he blew it up by feeding it into. So like, just know that, don't drop stuff across the poles, all these kinds of safety things. So we really actually do care that you don't get hurt. You don't set your school on fire. You don't, you don't learn those lessons that way. Don't damage any property. Next slide. And I think this runs back to you, Remy. You get to share a little bit about this really fun, unfused system.
Yeah, I won't say anything about that part. Yeah, well, before I show you this example, I thought maybe we could break and see if anybody had any questions for you, Charles.
Sounds great. Because that was a little bit of a fire hose. And
Yeah,
again,
thank you. I just wanted to mention that thank you, Charles, for this really informative information for us. So basically, you don't want the students to put too detailed information, but just cover the like outline, single line diagram, and some specifications of the design to be more easy if some other schools or someone else want to implement the same approach. And then you don't have any limitation in terms of the number of page for the reports, or so the template, basically we have to cover those sections, but there is no any like a standard template or limitation of the pages, right?
No,
we
we've never
wanted it
done
to
this
be
before.
yeah, we wanted it to be pretty freeform and for you to be responsible for making it age appropriate and skill appropriate, right? So we didn't want to make it awful.
Yeah, and how about the result, like a waveforms, experimental waveforms, if they have done some simulation waveforms, should we also add those as part of technical?
Yeah,
Okay.
I mean, so when you think about where your students are, you've got engineering, electrical engineering students. This is like child's play to them, right? So then how do we make it educational for them? Well, they should work a little harder and they should write up a little bit more and they should educate other people who don't understand it as well, right? That's their job, is to kind of give us a product that's going to be useful for, for people, but try to write it in a way that is understandable by people who are not electrical engineers.
Oh,
that would be very
thank
helpful.
you.
Yeah.
Thank you.
And
you bet.
Feel free to submit as much, detail as you have, because, we're going to have folks, sending feedback. So anything you want to be reviewed, but yeah, for the sake of like a DIY project, we don't necessarily need all those details.
Yep.
Awesome. Were there any other questions?
Sweet.
Go ahead.
Oh, I was wondering, what software did you use to do those technical drawings? Was it AutoCAD or?
This is embarrassing. Okay, it wasn't SketchUp. Okay, that was good, but it's an ancient. This is the thing, you guys all are really smart, young. Your brains are still functioning. If I gave you a new drawing program, you would be able to do it. Me, I'm crusty and stupid and brittle, and I cannot learn anything new.
Oh.
And so I use AutoSketch, which is an Autodesk product that went out of print like in 2009 or something like that. But it works fine for me. I know how to do it efficiently. But you could use AutoCAD, you could use SketchUp, you could use PowerPoint. I have made plenty of single line drawings in PowerPoint. It really does not matter what you do it in.
Okay, great. Thanks.
Yeah.
Yeah, good question.
Yeah, it's a great question.
Awesome.
Cool. Thanks, Remy.
Yeah, and so I just wanted to kind of show you this example project. I was honored to work on this project here in Virginia. This is a cute little renewable energy demonstration project. I'm kind of stopping on the picture because it's like a super cute picture. It's powering these lights in our holiday display on the beach. So you can see the sign. It was, sponsored by Dominion Energy. It's really promoting our coastal Virginia offshore wind project. And it says this light display is powered by clean wind energy, which is a little bit of misleading because it is wind and solar. So the cool thing about this one is that the design team was a bunch of students, high school students from the environmental studies program in Virginia Beach. So I was happy to consult with them and help them find system components. But because they were in the area and I was far away, they got to build the whole thing by themselves. And as Charles mentioned, I believe there's not a single safety feature in here, so don't judge. They're still learning. This is, I think, the second or third year this has been installed. And so their client is the city of Virginia Beach, and specifically the Surf and Rescue Museum, which is on the boardwalk in Virginia Beach, and actually has a display about the power of the wind inside the museum. And if you go to the top of the museum, you go to the Widow's Walk up there, there's a telescope and you can see the 2 offshore wind turbines, which is pretty cool. But this is their Holiday Lights power system. And so the idea here, their objective was to educate the public about renewable energy, specifically offshore energy. Their load was mainly the Holiday Lights display during the winter. And then the idea, and I'm not sure if this has actually happened or if it's still something they're hoping to do, is that they want to be able to power amps and mics at the outdoor pavilion that's right next door to the museum during the summer when they have concerts there. So they, I don't want to say over-engineered, but they kind of created a system that could be used in many different ways. The Holiday Lights are DC load, but they still have an inverter because if they do want to, in the future, power amps and mics, they're going to need to have AC power. So they're kind of inverting it to then invert it back again, which is kind of crazy, but it works for them. So in terms of their system components, they have the Air 40 marine system. Because they're on the water, they had to have a marinized small wind system with the Silent X blades. And they also paired that with a 400-watt solar panel, which for this particular project happened to be donated to them. I also donated the tower for the turbine, so they only had to pay for that for the turbine itself, and they didn't have to pay for the tower. And I mentioned this because in the end, this was under $5,000. But if you had to buy all those components and not get them all donated, it might be a little over $5,000. So just to give you an idea of how much this thing costs. They also had 2 12-volt deep cycle batteries. So they're not lithium ion, they're super old, you know. Well, I don't even know what they're made out of these days. the lead acid batteries, maybe. The wind turbine and the solar panel both have their own control panels. And then it's hooked to an inverter. And then of course there's assorted cables that you need for, you know, moving the power around. And then they had to develop a waterproof box for all of the components because it was going to be outdoors and on the water. So that is the main gist of their components. You have this fantastic diagram that he sent of their wind turbine and their solar panels. And in this one, I don't know, they were having some trouble, and maybe I will hook them up with Charles later, but they're having problems figuring out how to take the wind turbine, the energy produced by the wind turbine, and combine it with the energy produced from the solar panel. So they actually just have the solar panel hooked to one battery and the wind turbine hooked to the second battery. And then both batteries are hooked together in parallel and hooked to the inverter. So it's a little bit of a Frankenstein thing going on there, but it works for them. The big thing that they told me in terms of some of the challenges were they needed to have some safety considerations when it's deployed in a public space like this. So, you know, how are they going to kind of lock things down? They also, you know, just had to take into consideration overall safety when hooking the system up to the live batteries, because they didn't build in some of those, you know, circuit breakers and things like that. And then the last thing that they, you know, were talking about was that they had to create a rack for the panel when it was deployed, because you can't just lay it on the ground, right? It has to get put into a position that's suitable. And then the one last thing that he mentioned to me that I did not put in the slide, but one of his suggestions was, sorry, my daughter just came home from school, was the idea of considering sighting when you're doing this, because for them, if the wind blows in a certain direction, the museum actually shades the turbine. And then throughout the day, the solar panel itself gets shaded by surrounding buildings. So considering your sighting is very important as well. And with that, I want to stop there, but Jin, I didn't know if you wanted to talk a little bit about the system that you have at ISU, if you think it's relevant.
Yeah, we had we actually installed one back in try to remember like back in 2009, little 1 kilowatt the Berge system with 1 kilowatt solar system is still there, and then with the battery storage system. But it was a demonstration project for the students to show them how things work all together. But maybe the Remy, you would remember that we reached out to you that the 1 kilowatt Berge system was not functioning. The problem with the cables and so on. So we took them down, and then we replaced the smaller with the smaller wind turbine a couple of years back with the students. Now we have an issue with the battery storage system, so we're thinking to replace it anytime soon. So in the works, discussing with the university, but it might be a good project with the students. The charts I think that you mentioned about the Homer software. I've been using it, very powerful tool, but yeah, I agree with that. It might be overkill if you try to design the small hybrid system. And I like the functionality, but I use it for different projects and so on. But in terms of utility of the system, we do have the facilities. The folks use the hybrid system to charge the batteries for the tools and so on, and then outdoor lighting, and then we do have a horse center out there, and then we have outdoor classroom where student could charge their laptops and the cell phones and so on. So we want to have that function back by replacing the battery. But also, it'll be an interesting student project to have them design the system to carefully, sizing the battery with the existing solar and wind system out there. Yeah, it's an interesting project.
Awesome. Well, thanks for sharing, Jen. And with that, I think we're kind of done sharing the bulk of our information. I did want to talk with you guys, at least to get the save the date out there for you all for the Distributed Wind Energy Association's 2024 conference, where we'll host our student symposium again this year. But before I get into this, I will take a break. Does anybody have more questions or any comments or anything before I give you these details, and then we can go around the room?
Remy, I was going to mention two things real quickly that I forgot to mention. One was you said the magic word circuit breaker, and I appreciate that because I had forgotten. And I mentioned fusing, but circuit break for those of you that don't know why a circuit breaker is nicer than a fuse, it's more expensive, but it's resettable. That's probably the most useful thing, is you don't have to keep making trips to the hardware store. The second thing about a circuit breaker is that it's tempting to want to put a switch on things, right? To switch the solar on and off so you can work on it or whatever it is. Problem is that it's really hard to find switches that are, residential switches at Home Depot that are larger than 20 amps. And they're not really meant to be switched under load anyway. They're in the world of AC. There are 16, or is it 16? No, it's 60. Sorry, 60. 60, or is it 120 zero crossings per second, right? So it's 120. So there's a lot of zero crossings. So there's not much arcing concern with AC current. But in the DC world, there's a big old arcing concern. And so even circuit breakers, you don't want to go to Home Depot and pick up a DC circuit breaker. Because they're going to be subjected to, they're not going to play well with DC power, or they may not. And so their power rating is a little bit off. And you can use a 40 amp as a 30 amp circuit breaker or those kinds of things. but just know that it's better to get solar rated circuit breakers because they are truly DC. And then if you want to use switches, you're allowed to use switches, just use a knife switch. And what's a knife switch? A knife switch is literally a switch that is like a knife, and it goes between two. And so they have battery disconnects, which are knife switches. And you've seen them in 4th grade science, right? The electrical circuit thing is like the little lever. That's a knife switch. And that is arc sort of tolerant. And those you can, and the question is, where do I find, well, aside from Amazon, where you can find everything, you can also just go to an RV store. So RV recreational vehicles, you know, those kinds of things have lots of DC components, including battery disconnects. And battery disconnects are going to be one of those things that's hard to find, really impossible to find at Home Depot. You can find them online and they're pretty cheap and they come right to your door. It's just a different world now, but you can also just go to an RV store and kind of get everything you need. So that's just one comment I want to add it in there, because if you don't know where to look other than Amazon, it can be tricky. And if you think that they're equal, DC and AC are equal, then it's a rude awakening. So, or can be. So just be prepared for that. All right. Now you can have it back. Sorry, Remy.
Oh, no, you're good. I think it's important clarification, and I'm sure they appreciate that. I know I appreciate it because I don't know what I'm doing here. So awesome. Okay.
Remy, I have just one quick question that is there any platform or link you share with us to submit the final report, or we have to email to you?
That is a really good question. I think at this point, it's probably just as easy just to email it. But I will give you more details before the submission date, and I'll talk it over with Charles and Ian, because they're going to be responsible for helping me review them. So
thank you.
Okay, that's a good question. Awesome. Okay, well, like I said, I just wanted to kind of give you the heads up on the dates of the Distributed Wind Conference. It will be in Arlington, Virginia, Crystal City, at the Residence Inn. And it's the last week in February, the 26th through the 28th. So it's a Monday, Tuesday, Wednesday. For those of you who, I think there's only a couple of you on the call that participated last year, but on Monday, we are invited to join the conference. So go to the conference, you know, listen to the talks and participate. And then on Tuesday, we will have our own programming for the students. They'll get the opportunity to meet some specific folks that we invite to speak with them. We'll have some specific programming. And then the Tuesday evening, we are invited to the reception for the conference, and the students will have an opportunity to present a poster with their results. And that's at that point, it would just be your technical documentation, your, you know, the things that you are submitting to us, but in a display form, like a poster, so that you can get a lot of industry feedback from the folks that are in attendance at the conference. And so it's a networking opportunity. And they're all hiring, so it's also a great opportunity for internships and jobs. So that's a fantastic opportunity. And then on Wednesday, we will be doing some sort of a field trip or tour or something locally, because that's the day that the conference goes to Capitol Hill and does their lobbying part. So that's not something that we usually participate in. So that is kind of the really broad strokes of the agenda. If you Google the DWIA 2024 conference, you can look at the detailed agenda as it evolves. It looks like Monday is pretty well settled in, but the rest of the days don't have an awful lot of speakers lined up quite yet, but they will continue to update that. So if you want to keep going back and seeing what the plan is. In terms of a location, the Residence Inn pretty much only has space for their conference. It's just one conference room. So we have to find a nearby location to host our parallel programming on Tuesday. So for now, just know that it'll be in the area. We're still working on like a particular hotel to get blocks of rooms for you all. And I also need to look at how much travel support we may have, because we didn't have all 10 college and university spots filled in the research project. We may have some funds that we can use from for those schools that didn't participate. We might be able to reallocate them to some travel funds for you all. And anyway, and so I'm also looking at tour ideas. Amazon has its headquarters in Crystal City. So we're talking about maybe touring the Amazon headquarters. But if you have any interests or thoughts that you want to throw out to me as I'm looking into kind of solidifying these plans, please don't hesitate to reach out. That again, I'm hoping we'll have some travel assistance. It wasn't originally in our budget, but because we have less schools participating, we can either put some money into travel assistance for you guys, or we can give you some extra money to help with the installation of your projects. So it's a balance. So I'll be looking forward to your input on what you would rather have, some travel assistance to get to the student symposium, or extra funds for installation. So that's it. And so with that, we're going to open it up to, we don't have a ton of time for around the room, so maybe just open it up to a discussion. And then if anybody has anything pressing they want to chat about, we can chat for the next 5 minutes.
Given the 4 seconds or 6 seconds of quiet, I'm going to say something on Ryan's behalf, and just to give him a little pat on the back, and just sort of say, you know, one thing I was reminded of when I had a call with Ryan and Octavio not too long ago is that they're students and they're motivated to do well, and they try to do well, and they try to do what's required of them. So Ryan, one of his questions was, what's going to be required? And it goes back to this technical, you know, document or whatever that we're asking for. And again, I would say there's not really a wrong answer other than to say, I once got a grant request for something like 80 grand at the USDA, and it said, I want a wind turbine. It's like, that was it. And oh my God, we had to put like 1.3 million back in the hopper because we didn't have enough grant applications. So we gave them their 80 grand. For that statement. So there's an example, real world example of like, sometimes there's just not a wrong answer. But
remember, we're not giving you money. I mean, this is not contingent on you getting money, right? So it's just,
that's right. That's right. So it's not meant to be a hardship. It's meant to be an opportunity. And we are here to give you the support you need in order to be successful. And we're just trying to give you something fun to do. So just keep that in mind. It's not meant to be a hardship.
I think that's really helpful. Yeah, I mean, you guys are stressed enough at the end of the semester, and I know this is probably for a class. For some of you, it's for capstone. But either way, like you said, you know, we're not looking to pass or fail you here. We want to see what you've been up to, and we want to provide you the opportunity to submit it for feedback from industry experts, so that you can move on to the next phase and really go through the implementation part of it, which is the fun part, right? You design something on paper, and the next part is like, let's see it really happen. So yeah, so no, don't stress. And
we're probably not going to review anything before the new year. So do your own time management. If you want to have a nice Christmas holiday or whatever, winter holiday, and you don't want to think about anything, then get it done beforehand. If you're like, I got a lot of stuff to do that it's going to affect my GPA, I'm going to focus on that stuff. And over the Christmas holiday, I'm going to spend whatever time I want to get it right. You're totally able to do that. And we're not going to, so we kind of put a light and deadline of end of year. So interpret that in a way that is supportive of your mental health. This is not, keep it, we want to make it easy. We want everybody to be successful. Cool.
Awesome.
Sweet.
Yeah, thank you so much. Really appreciate for giving this opportunity to students.
You bet. And in the last 3 minutes, not to keep you any longer, feel free to head out if you need to head out. Just if you can let me know if you would prefer travel assistance for DWIA, like if you're planning to go, or, you know, if you'd like to see some of that money put back into your implementation funds. just so I can get a handle on how we're gonna move forward with the DWIA plans. So I appreciate any input that you all have, and just like you want to go or you don't want to go.
Depending on their performance for my team. Right? Duncan is listening. So if they did
I
a
was
good
thinking
job, they did that wonderful, amazing design, they're welcome. We'll ask you to sponsor their travel trips. Right, Duncan? That
Yeah.
will be an award for them.
Yeah, I
right?
think my team also would love to have assistance in terms of the travel.
Okay, that sounds great. Okay, well, that
Us
gives
as
me
well.
something to go on, so. Wonderful. Okay, well,
you.
guys, have a great rest of your day, and thanks again. We will be in touch via email with more details on submission, but go do good things.
Thank you guys so much.
Bye-bye.
Awesome.
Thank you.
Take care, guys.